So, second lecture. This is a continuation of the first lecture, which was about logical implication and also about logical equivalence. Also, only briefly mentioned logical equivalence. Logical equivalence actually means that the implication is in both directions. So, actually, this means that both statements are true or both statements are false, because if we have a false premise, then the conclusion may be true or false. So, if we have a false premise and a true conclusion, then this is only true in one direction, because having a true premise and a false conclusion is false. So, two statements are logically equivalent only if, and we would actually say as computer scientists, if and only if both of them have the same logical value. That is, both of them are true or both of them are false. But not that they have two different logical values, one of them being true and one of them being false. And now there are many operators in logic, and maybe you have heard about them. One of the most important ones, of course, is logical negation. So the logical negation of true is false, and the logical negation of false is true. And, well, if a statement is not true, it must be false. And if it's not false, it must be true. There is no third possibility. And this is a principle of tertium non datur, the law of the excluded middle. In classical logic, this is one of the basic laws. So there is only true statement or false statement. As soon as you have proven a statement not to be true, it must be false. So now, what does that mean? Now, think of this. A implies B. Let's say this is true. So, for example, A is a true statement and B is a true statement. So, what is the negation of B? It is a false statement. Well, then if B is a false statement, what does this mean for A? If we have a premise that is a false statement, then the conclusion can be true or false. So, in this case, well, it is true that not B, the negation of B, implies the negation of A. In this case, also it implies A. So this is undecided. But in the general case, let's say A is false and B is true. Well, in this case, the negation of B, false, again implies both A and not A. What is if we have a false statement implying a false statement? A is false and B is false. Then the negation of B becomes true. And that means that the conclusion, if we start an implication with B being the premise, must also be true. This means that if we have an implication of the form A implies B, we can only say that for sure not B, that the negation of B implies not A, the negation of A. But we cannot be sure that the negation of B also implies A. And this is one of the basic principles in mathematical proof theory. because it is an indirect proof. We can prove that something must be true by showing that the reverse of it, the negation of it, cannot be true. And what I also wanted to tell you about is that, of course, implication is one of the most prominent logical operations, but there are, of course, many others, and two quite basic operations which, in case you haven't dealt with logic before, haven't been mentioned in my lectures yet, are conjunction and disjunction. And conjunction, this is the AND operator for those who have some knowledge in computer programming. And disjunction, the OR operator. So if you say A and B, then this statement, A and B, the conjunction of A and B, is true only if both A and B are true. So A must be true and B must be true. And in this case, it's also an if and only if relationship, because the two statements are logically equivalent. The conjunction of A and B is true. This statement is logically equivalent to the statement A is true and B is true. So we can reason what implications this has. It's actually quite simple. If A is false or if B is false, then the conjunction A and B is also false. So it is enough for one of the two to be false, so to make the conclusion false. And with disjunction, it's quite, well, the opposite, because in this case, it is enough that one of the two values is true for the disjunction to be true as such, and only if both statements are false, the disjunction will be false as well. And the reason why I actually mentioned these two operators now is that implication is logically equivalent to a combination of negation, conjunction, well, negation and disjunction. So if you have A implies B, this is logically equivalent to the negation of A or B, or let's say the disjunction of the negation of A or B. And you can simply, I cordially invite you to try out what happens if you set A to true, B to true, or A to true, B to false, A to false, B to true, A to false and B to false, and check out what the values of the two statements are. So you will see here we have a logical equivalence, because the one side with the implication implies the other side with the negation and disjunction, and the side with the negation and disjunction implies the implication. So it may sound a bit tough, a bit difficult for beginners. Basically, this is almost all you need to know about classical logic. And actually, classical logic is almost all you need to know about logic in order to become a computer programmer. because the non-classical logic, the modal logic, the intuitionistic logic, and the multi-value logic and fuzzy logic, all of these are fancy things, but basically, if you know classical logic, then you know what you need as a programmer. Believe me, trust me. So, thanks for watching and see you